Cancer is a big issue that our society faces today. There are fundraisers and awareness days to bring this issue to everyone's attention. But when it comes to the treatment of the cancer, things can get a bit more complicated. There are multiple ways to treat it, and throughout our video we will explain how external radiation beams work to destroy the cancer cells. External radiation beams are used to emit beams through tissue in the body to target cancerous areas. The beams are made up of different kinds of electromagnetic waves and subatomic particles. These waves and particles carry ions, a charged molecule, through tissue, the cancerous areas where the ions destroy the DNA of the cancer.
Gamma rays are a type of electromagnetic radiations. They often accompany alpha and beta particles within the radiation beams. They are a radiation hazard from the entire body, meaning that although they will pass through you, your tissue will absorb the high energy they emit. X-rays are essentially the same as gamma rays, but their origin is different. Gamma rays come from inside the nucleus, while X-rays come from outside the nucleus. These electromagnetic waves make up different kinds of radiation beams to treat cancer.
In addition to the electromagnetic waves that make up the radiation beams, there are different types of particles. These particles include alpha and beta particles and neutrons. Alpha particles are positively charged particles that have very limited ability to penetrate materials. They can be blocked by a sheet of paper, skin, and even air. These particles hold a potential danger if they are inhaled or swallowed, but external exposure does not normally pose a threat. Beta particles are negatively charged particles and are similar to electrons. Electrons are particles with a negative charge found in the nucleus of atoms. Compared to alpha particles, beta particles have a greater ability to penetrate materials, and it takes more material to interfere with them. Neutrons are very high-speed particles and have a greater ability to penetrate materials than both beta and alpha particles. Neutrons can travel great distances, and it requires a thick material containing hydrogen to block them. Unlike both alpha and beta particles, neutrons have the ability to transfer their radiation to other objects.
The different electromagnetic waves and subatomic particles just covered make up different kinds of beams that affect the body differently. The two beams are referred to as indirect and direct ionizing beams. Direct ionizing beams are made up of protons, a positively charged particle found in the nucleus of an atom, alpha and beta particles. Altogether, they work to distribute the tissue they are passing on a molecular level. This prevents any harm to the tissue as the beam passes to the infected area. On the other hand, there is indirectly ionizing beams. These beams use X-rays and gamma rays and neutrons, particles with no electrical charge. When this beam passes through the tissue, it releases a high energy level of X-ray and gamma ray waves. This level of energy creates fast-moving particles that can harm surrounding tissue, but in turn destroy the surrounding cancer cells. Both of these beams have the capability to break apart the double-stranded DNA of the cancer cells. We now know that radiation beams are made up of different EM waves and particles. I hope this video gave you a better understanding of how cancer is treated and encourages you to support your local cancer fundraisers. There will always be more time to research better ways to treat this disease, and your support helps.